Greetings, ladies and gentlemen. We're starting now the actual trigonometry part of the trigonometry unit. Yesterday, you should have gone over the triangle basics. You should know how to do Pythagorean theorem. You should know how to get a missing angle in a triangle if you know two of them, as in all the angles add to 180. And you should remember something about similar triangles, mainly that the ratio of the sides are the same for all of them. And so, actually, before we start filling in these notes, which you might have started already, I'm going to mention a couple things about triangles. So, like I said before, if two triangles are similar, the ratio of the corresponding sides are equal. So, meaning, like if I have a triangle here, and I know I got these side lengths, 1, 1, square root of 2, and I know it's similar to this one which happens to be bigger, right? It's 2, 2, and then 2 root 2 is my side lengths. The ratio of the sides is going to be the same. So if I look at this, the hypotenuse over this side next to it, that's going to be root 2 over 1. Well, on this triangle, it's also the same. If I do this side over this side, that 2 root 2 over 2, that'll simplify to be the same number. These are the same. And so no matter how much bigger the triangle is, say I got a ginormous one, which doesn't look the same. If I got a ginormous one, and I know this is 10 and this is 45, if I just knew that information and I knew it was similar to my starting one, I could get this side length just using that knowledge, that this over 10 is going to be the square root of 2 over 2. So it's just kind of the big idea behind trig. The ratio of corresponding sides is equal. And this is a really big deal. It actually makes it so you can measure things that are really hard to measure. So let's say you're exploring Central America and you find an ancient Aztec building. Is Aztecs? Or was that Meso? Anyway, south of us, you find an ancient Aztec building. You want to find how tall it is. Well, measuring that like by hand is actually really difficult. But if you have trig and you set up a little trig equation, you can find it out pretty easily. So let's say you walk away from it about 10 yards and you measure the angle here, which is pretty easy to do. You could then find out how tall this building is using trigonometry. And we're going to get to that point. But today it's mainly focused on some vocabulary and what these trigonometric ratios are, which you should try saying that word a few times. Trigonometric, trigonometric, trigonometric. It's fun. You know, if you haven't tried it yet, try it. It just kind of rolls off the tongue. Or you can say trig for short. So we're going to start with some vocabulary and dive in from there. So if you have a triangle, there's going to be one side, that's the hypotenuse. That's the same as always. It's directly across from the right angle. And then there's going to be a side that's called opposite and a side called adjacent. And what side is adjacent or what side is opposite depends on what angle you're referring to. And so there's this symbol here in the corner. This symbol is called theta. Theta. At least that's how we say it. It's a Greek symbol. It's a Greek letter. And that stands for an angle. So this is an angle theta. We just picked this angle. But these sides are called opposite and adjacent because they are opposite our theta or they're adjacent to our theta. So if you're looking at your main triangle, this side is across from our theta, our reference angle, and so it's called opposite. This side length here is right next to my angle, and so that's why it's called adjacent. And you may be a little lost why that's adjacent and this one is not, and the answer is because hypotenuse is always hypotenuse. It is the biggest side is across from the right angle. And so the hypotenuse will never be called adjacent because it's always called hypotenuse, which means our other side that's next to our angle is called adjacent. And now you know what the names of the sides are. Remember, it's referring to with respect to the angle. This one's opposite the angle, and this one's next to it or adjacent to it. There are three main trig ratios, which if you like filling things in, you can pause and fill in some blanks here. But there are 6 trigonometric functions or 6 trig functions, and these trig functions are called sine, cosine, tangent, and these are the three main ones. We're going to use these ones pretty much entirely, though sometimes you'll see the other ones. Sine, the trig ratio of sine, is made when you take the opposite side length and you put it over the hypotenuse length. So if I had an example triangle here, say, let's call this side a side length of 3. Let's say this length over here is 4, and this one's 5, which would be a right triangle. If I was trying to say what the sine of this angle is, I'd say it's 3 over 5, because the opposite side length is 3, and the hypotenuse is 5, so the sine of this angle is 3/5. And then there's cosine, similar name, but that co makes a big difference there. And the ratio is made from adjacent over hypotenuse. And I'm just going to kind of quickly redraw my triangle here, just so I don't have to keep scrolling over to the other one, the big one. And here's my theta. So if my angle is here, the adjacent side is 4, and my hypotenuse is 5. So this ratio would come out to be 4/5. And then tangent is the third main one, and that's made from the opposite side length over the adjacent length, opposite over adjacent, which, if we're referring to this angle, the opposite length is 4, and the opposite one's 3, and the adjacent one is 4. So this ratio for this triangle would be 3/4. And this here is a handy little thing, a little phrase, a thing that people say that kind of helps them remember. It's so ka toa. So ka toa. And if you write out those letters, it tells you that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So say that a few times. So ka toa, so ka toa, so ka toa. And that kind of helps you remember what the ratios are. Is it opposite over hypotenuse, or is it opposite over adjacent? Which one matches? That's something you want to memorize. Even though you can use your notes for now, you'll want to memorize it. It just makes things faster. There are 3 other trig ratios, and they're really similar to the other ones. In fact, they are just flipped versions of the ones to the left of them. So this one is cosecant, and its ratio is sine upside down. So instead of opposite over hypotenuse, it is hypotenuse over opposite. And if we're looking at our triangle we've been working with, let me kind of redraw here. If we got 3, 4, 5, and this is our angle we're referring to, then the hypotenuse over opposite, in this case, would be 5 over 3. That's a bad 3, because hypotenuse, and then 3 is opposite of our angle that we're referring to. Secant is the same as cosine, but upside down. So instead of adjacent over hypotenuse, it's hypotenuse over adjacent, which for our triangle here would be 5 over 4. And then cotangent is the same thing as tangent, but upside down. So instead of opposite over adjacent, it's adjacent over opposite, which for our reference triangle here, our adjacent's 4, opposite is 3, so it would be 4 over 3. And again, if you like figuring out your kind of a phrase that helps you, you can think it as cho, sha, ko, which isn't quite roll off the tongue as well, but you get it. Mainly, if you memorize that these over here are just these upside down, that'll do you really well. Memorize these ones. We're going to use them way more than these ones. So if you're trying to prioritize your time, focus on these ones. We use them, not so much these ones. But you need to know that these exist and how they relate to the other ones. And so, now we've done that, what's going on for the rest of this assignment is you're going to be confronted with a triangle, and you have to figure out what the trig ratios are for the given theta reference angle. And so let's do that as an example here. Let's say I have this triangle, and let's switch colors. Let's do green. This is my reference angle, and you're supposed to write down all 6 trig ratios, which will mean 8 is opposite, 15 is adjacent, and 17 is my hypotenuse. And so I'm going to start writing out my trig ratios. Sine of theta is opposite over hypotenuse, so that's 8 over 17. Cosine of theta is adjacent over hypotenuse. Adjacent is 15, hypotenuse is 17. And then tangent of theta is opposite over adjacent. Opposite is 8, adjacent is 15. So I got my ratios there. And then the other ones, there's cosecant, which when we write it shorter, it's just CSC of theta, is going to be hypotenuse over opposite. Secant of theta is hypotenuse over adjacent. 17. I got that wrong. This is 17. Hypotenuse is 17. Adjacent is 15. My bad. And then cotangent, or cot, of theta is adjacent over opposite. So there's my 6 trig ratios. And so you're just kind of getting used to writing out what numbers go where to make the ratios. And on some of these problems, you're not given all the sides. So I want to jump to one that's actually a little bit harder. Yeah, sorry, I'm making decisions right now. Yeah, let's just go to this one. So on this one, you don't know the hypotenuse length, and so you have to figure it out. Luckily, there's good old Pythagorean theorem: a squared plus b squared equals c squared. The hypotenuse is c, and that would mean this is a and b here. So I'm going to use 5 squared plus 12 squared equals c squared. 5 squared plus 12 squared comes out to be 169. There's my c squared. So now I just need to get c by square rooting. And the square root of that, I believe, is 13. Yes, indeed. Remember, normally when we square root, we do plus or minus, but since it's a side length, it can't be minus. So our c is going to be 13. So the side length here is going to be 13. And now I can write out my ratios. What I recommend is pausing the video and see if you can write out sine of theta. And remember, our theta is here this time. So that means 12 is opposite, 5 is adjacent. That's a bad J. And then 13 is our hypotenuse. So write sine of theta, cosine of theta, tangent of theta. You write out what those ratios are. And then don't forget your cosecant of theta and your secant of theta and your cotangent of theta. So yeah, go ahead and pause and write out your ratios. All right, let's see how you did. Did you get 12 over 13? Did you get 5 over 13? Did you get 12 over 5? So I'm just getting these real fast. It's opposite over hypotenuse. Then it's adjacent over hypotenuse. Then it's opposite over adjacent. I'm just writing out the fractions. Now I'm going to do cosecant, which is hypotenuse over opposite. And then secant is hypotenuse over adjacent. And then cotangent is adjacent over opposite. So those are my 6 trig ratios for this triangle. Remember, which side is opposite, adjacent, and hypotenuse is referring to the theta. So if I was using this angle down here instead, these would all be different. They'd be the same numbers, but the ratios would be different. If I was here, this would become opposite, and this would be adjacent, and so my fractions, my ratios would be different. But that's how you go about it. Some of these, you got all the sides already, such as 2 and 3. Some of them you don't have the sides already, and so you figure them out. Use your a squared plus b squared equals c squared. And there's one last thing I want to show you is sometimes your ratios simplify, and so you should simplify them. So let's say I jump down to 7. Here's my theta, which means 7's opposite, 21 is adjacent, and 14 root 2 is hypotenuse. If I write out my sine, which is going to be 7 over 14 root 2, that simplifies, right? Those simplify, you get 1/2. But this also has a square root of 2 in the bottom, and we don't want to have square roots in the bottom, and so you can times top and bottom by root 2, which I'm kind of running out of space here. You'll get root 2 over 2 times root 2 times root 2. Root 2 times root 2 is root 4, which is 2. So this becomes 2 over 2 times root 4, which is root 2 over 2 times 2, which is root 2 over 4. So this is actually what's going to be here for my sign. That's the simplified version of my answer, so root 2 over 4. So yeah, sometimes your fraction can simplify, and you should get used to simplifying them. But there you go. So you're just going through writing out your trig ratios.